So for question 24, they give us this 0.112 molar solution of benzoic acid. And they tell us the percent deprotonation is 2.3%. So we'll just call benzoic acid our generic weak acid. So that means it reacts with water to form hydronium and the conjugate base, A minus. And so our percent deprotonation, they're basically looking for how much of that benzoic acid is in the form of the conjugate base, so A minus. So our percent deprotonation would be basically our concentration of the conjugate base, A minus, all over the concentration of our benzoic acid, right, times 100. So we want to work backwards and basically find what is the concentration of the conjugate base, because ultimately we're looking for the pH of the solution. Would have been helpful for that at the start to know. Guess I got halfway in and then realized, what are we solving for? So we're eventually looking for the pH. We can find the pH after we find the concentration of the conjugate base, because these two concentrations should be the same. So my percent deprotonation is 2.3%, which when we get rid of the percent is 0.023. So that equals the concentration of my conjugate base all over the concentration of my acid, 0.112. All right, so we're going to multiply. So the concentration of my conjugate base equals 0.023 times 0.112. And my conjugate base is about 2.576 times 10 to the minus 3 molar. Now we can find the pH of our solution. We don't even need the Ka, because the concentration of the conjugate base is 2.576 times 10 to the minus 3, and it only came from one place, right? It all came from the benzoic acid, right? That would be the same concentration as hydronium. So our hydronium concentration would also be 2.576 times 10 to the minus 3 molar. So now we can directly find pH. It's a negative log of my hydronium concentration. All right, pH equals negative log of 2.576 times 10 to the minus 3. pH of that solution, so negative log. All right, I get a pH of like 2.59 for this solution. Concentration, so 2.589 for the pH.